Okay, so it's 7:03. I think we guys should start. So, good evening, everyone, and welcome to today's webinar. My name is Prateek, and I'm Extension Coordinator at Peace Country Beef and Forage Association. And I will be hosting today's webinar. And this webinar is about a province-wide research project on perennial, cereal, and legume intercropping in Alberta. This project is led by Dr. Keem from PCBFA, and our presenters today are Cosmos and Dr. Hayford. Cosmos is the PhD candidate at the University of Alberta and is coordinating this project at various locations in Alberta. Dr. Hayford is the research coordinator and is coordinating this project at the PCBFA location. Before we start, a few quick notes, like your camera and microphone are turned off during the presentation. Please type your questions in the Q&A section. We will take the questions in the end, and this session is being recorded. So let's get started. Dr. Hayford, over to you.
Okay, Patik, thank you very much. I'd like to say a very good evening to you all, and thanks for making it a time to join us on this evening's webinar. I hope that you are keeping warm wherever you are, or better still, enjoying the nice weather we've had these few days. Thank you for joining. So as Patik rightly said, my name is Hayford Jamfi, and I'm the research coordinator with Peace Country Beef and Forage Association here in Fairview, Alberta. And as an applied research association, we undertake various research throughout the province. And I am the research coordinator with Peace Country Beef and Forage Association. Because of that, this project is one of the crucial projects that I've been working on over the past 3 years. So it is my duty as a project lead on this project to kind of give a background to what we've been doing so far with this project. And then after that, I would hand it over to the research student, the PhD candidate, who has more insights with data and other stuff. So as I said, the perennial cereal grain crop trial, I should say that it's a dual purpose trial, research trial that we have been working on for the past 3 years. I should state that we are doing this in conjunction with about 5 ERAs, that is Applied Research Associations, province-wide. So down at Oyen, we are working with the KERA. We are also working with GROW at West Log. Up north here, we are collaborating with Impera as well as with MERA. And then we as PCBFA is also part as making it the 5th ERA is working on this project. I should state that we're also working in conjunction with the University of Alberta on this project. So as I said, this project is basically a dual purpose project looking at how we can get grain as well as forages from a single seeding. So basically the idea was to be able to intercrop the traditional legume varieties that producers are used to, let's say the clover, the alfalfa, as well as the samphor, and then we intercropped it with perennial rye, as well as a wheat. I'm sure probably the PhD student is going to go over a bit as he goes forward with his presentation. So we see that there's sometime in 2022 across the 5 ERAs we are working with, that is around 2022. And basically we seeded them intercrop, but we're looking at how these intercrops could give us grain as well as the forage when they are seeded as in alternate rows or in the same row. When I'm talking about alternate rows, I'm talking about, let's say, having one row of samphor, and then the next row that follows is a cereal crop like wheat, and then the other row in the alternating manner. And then the same row seeding is just seeding everything together. So that was the idea behind the project. And as I said, as an ARA like Peace Country Beef, we coordinated most of the protocols that were necessary to carry out this project. So we documented how the fieldwork has to be undertaken. Basically, the objective of this project was to look at the grain crop as well as the forage crop, look at the nutritional value of the forage crop as well as the grain crop. And then in this challenging times when prices keeps going down for our inputs such as fertilizer, the idea behind it was to be able to see how much nitrogen can be biologically fixed into the soil using some of these traditional legumes that we seed in our cropping systems. And again, not just looking at all this, we also looked at how intercropping these legumes and cereal varieties can impact soil health in general. So will these intercropping be able to relieve the soil, alleviate the soil of some compaction? Will it improve the nutritional buildup as the years goes by? These are some of the things that I wanted to unearth looking at this project. And as I said, the research, the one who is really in charge of the research, the data and all that is our PhD candidate. So he would be able to give us more insight going forward. So basically, yeah, I just wanted to provide a quick background of what we are doing with this project. As I said, it started in 2022. We are getting to the final stages of the whole project. So I would like to pass it on to our student researcher. He is going to kind of give us some kind of insight into what he's achieved over the 3 years that the project began. So over to you, Cosmas.
Thank you very much, Hayford. You've almost said everything. So, but to start with, I would introduce myself briefly. My name is Cosmas. Excuse me. Can you share the slide if you don't mind? Hello, Mr. Patrick. Are you able to share the slides now? Perfect. Thank you. So once again, thank you all for joining. My name is Cosmas, and I'm a current PhD candidate at the University of Alberta. I'm working under the supervision of Dr. Guillermo. I think he's somewhere here. As Hayford has rightly described our project, so we're looking at the dual purpose perennial cereal grains and legume intercropping across the province of Alberta. And just to give a little bit of overview of what we do. So let me just describe a little bit of what this perennial grains actually mean. So basically, we are using two different cultivars of perennials. And one of them is Kenza. It's a trademark name for the intermediate wheatgrass that we use in this cropping system. And the other one is one rye. So this basically is perennial grass, basically. And it has been modified, and I would describe that more in a bit. So basically, they're similar to the annual grains, and the only difference is that they regrow every year. And originally, they were meant for livestock as a forage in the US. And in the recent years, we have been exploring them for grain productivity as well. And domestication started in the US by the Land Institute in Kansas, US. And it's very interesting to know that about 300 to 4,000 acres of land are being cultivated. But interestingly, 81% of these lands are only in the US, with Canada sharing only about 18%. So there's a whole lot of room for exploration on this species. So for the rye, perennial rye, so this is currently being developed at Agri-Food in Canada in Lethbridge Research Center. And just like the Kenza, it was originally meant for forage due to its high quality forage. But also in this current study, we are trying to see if we can cultivate them for grains in this system. Also, similarly to what we have in Kenza, more than 91% is currently being adopted in the US, as opposed to the 9% we have here in Canada. So basically, why do we care about perennial? So because just like we said, it's a double harvest, double gain. So basically, we are interested in how we can make use of the forage gains and as well as the grain. And also importantly, we're looking at how this cropping system, how these perennials are able to improve the soil health in the form of carbon sequestration or building the soil structure, improving the soil structure. And also, we have this benefit of lower input over time because as perennials, we only see them once in a year and we let them to regrow and we're able to harvest both the forage and the grain in the concurrent years without having to reseed. And it also helps us to reduce, it provides with other ecosystem functions such as reducing the soil erosion and reducing water usage. So basically, the research background is here is we're trying to look at the sustainability in terms of how we can make good of efficient use of resources and also to improve the yield in terms of grain and forage and also the quality. And yeah, so just to conserve the soil health improvement. So all of these are connected and they all get towards sustainability. So our key research objectives are one, we are trying to evaluate this wheat and rye species, and then we're trying to intercrop them with alfalfa, white clover, and sainfoin in two seeding methods. So one is the alternate row and the other one is the same row. And this way we're able to see their performance across different seeding options. And also we're trying to look at how much nitrogen credit we can get from the legumes, because as we all know, legumes contribute a lot to by adding like nitrogen to the overall cropping systems. And eventually, of course, as I've mentioned earlier, we are also trying to assess the soil health improvement from intercropping, especially in the soil structure. And I will get more in depth in that in a bit. So this research, just like Dr. Hayford had mentioned, so this is a province-wide research, and it run across from the north all the way to the south. I apologize because one of our collaborators, which is Oyen, I think I omitted that somehow, but I apologize for that omission. But anyway, so we have this site in the Fort Vermilion and in the Fairview. These are all in the north. And in the central Alberta, we have at Barhead, West Loch. This is actually West Loch, in collaboration with GROW in West Loch. So Fort Vermilion is managed by Mera in Fort Vermilion. And Fairview is being managed by Peace Country Beef and Forage Association, PCBFA. And at Breton, we have another site at Breton, which is managed by the University of Alberta, the Breton plots. And of course, the Battle River Research, the Forestburg site, and all of this site. And then most also, last but not the least is the Oyen. This is Cara. They have not been, we have not had much productivity from this side, but they have been very helpful in terms of helping us with data analysis and other collaborations. So just to give a little bit more of, to show how this site look. So this very site here is the Oyen. Unfortunately, we were not able to establish this cropping system there due to drought. And we tried the first and the second year, but we were not successful in that. But these are like some of the other sites. This one here is Forestburg, Breton is here, Fairview, Fort Vermilion, West Loch. So basically, yes, as I've explained in many ways. So, well, we have these two perennial cereals. From now on, you'll be seeing ACE1. So that basically means the perennial ryegrass species we're using. And the Kenza is we call it intermediate wheat grass because it's actually intermediate. That means he has been domesticated to give us this current cultivar that we are using this time. And we set up our experiment by intercropping them with these 3 legumes, well, the yellow-haired alfalfa, white clover, and sainfoin. And we are employed 2 seeding methods to do this. We have the same row, which is the mixed row system, and also in the alternate row system. So if you look here, these are the treatment description. So we have the perennial with mono as a monoculture, and also we have the intercrop with alfalfa, with the white clover and the sainfoin. Also for the perennial rye, we have the rye as a monoculture, and then they're intercrossed with these 3 legumes. So what we have found so far, I think I'll just run down quickly based on what we have found. So I'll be talking about the forage and the grain, what we've seen so far across the sites. And also I will talk a little bit about the forage quality. And then I will now talk about the soil health in terms of nitrogen fixation. And also maybe the soil quality, which they kind of overlap in a way, because soil health can be nitrogen fixation, and also the quality could be improvement. So they're all classified as soil health, but I will get back to that in a bit. So for the PCBFA sites, so I just wanted to show a little bit of what we have obtained. So in terms of grain, so these are the 2 grain yield from PCBFA for the 2 years. So we had the first production year in 2023 and in 2024. So for the first year, we saw the highest grain yield in pounds per acre was under this intermediate wheat grass, that's the Kenza, with a clover intercrop. So we're able to obtain about 670 pounds per acre. But in the second year, we saw a little bit of reduction. As you can see here, in alternate row, we have the highest, yielding at 508 pounds per acre. For the Forestburg side, that's the Battle River Research Group, we were able to obtain a little bit higher amount of grain here in the first year. As you can see, we were able to estimate the grain at about 780 pounds per acre. And then the second year as well, we saw a little bit of reduction in the amount of grain. I think we will discuss about that in a couple of minutes from now. For the growth side, so actually in the first year, we experienced the higher grain in the same row. So we can see the trend here is not, sometimes we have a higher yield in the same row, or sometimes we see the opposite. So these are very interesting, and we see this across the site. They have different performance in terms of grain and forage. So in the grain, in the second production year, which is in 2024, we were not able to obtain rain from the rye. And the reason, because there was an environmental damage. I would say that was hail just during the flowering, and that affected mostly the rye rye monoculture and the intercrop. So we're able to just obtain yield from the Kenza, that's the intermediate wheat grass. And for Mera, we only had grain yield for the second year. And as you can see, we only have intermediate wheat grass and their intercrop. And we're able to obtain about 1,050 pounds per acre of grain from this site, which is very high. But although we wish we could have had a more yield from the S1, but this is very promising from this side. And for the University of Alberta, we have for the first year, so this side is slightly different because compared to the other side, we had a fertilization. So we had some part of the plot fertilized and some other part unfertilized. And from what we can see here is that the fertilized part of the treatment, of course, revealed more grain, more productivity in terms of grain. And we're not surprised because fertilization boost the yield in terms of grain or forage. So for the forage, I'll go back to the forage again. So for the first year, these are the year we have. I'm not going to call out the numbers, but as you can see here, this is the first year we had just about 8,910 pounds per acre of forage. And then in the second production year, we're able to obtain higher yield here. So there's a wide variety, variation in this cropping. And yeah, so for grow, unfortunately, we were not able to have forage. Well, there was some mechanical issues that made us not able to have this yield. But in the second year, we were able to obtain the highest yield in the same row cropping, totaling about 8,006 pounds per acre. For Mara, we have the highest grain yield produced, about 12,328 pounds per acre. And this was obtained in intermediate wheatgrass and alfalfa. But I have to mention that at Mara, we had a little bit of problem with the seeding in terms of the legume establishment. So most of these yield were not directly influenced by the legume intercropping, but mostly from the perennial grasses. So for the resin plots, we have a lower yield in the first year, and mostly in the fertilized plot. And then in the next year, in the second production year, we had about 10,200 pounds per acre of forage being produced from this site. So I'll move forward to what we found in terms of the forage quality. So I try to look at how these forages, how nutritious they are, how in terms of quality. And you might be wondering why I chose this H1 Senfine in this case. Well, of course, we have a total of 8 treatments across the site, but I thought it was very interesting to show this Senfine because I see a very interesting trend here. As you can see, these are the yield from each of the sites at Fairview, at Forestburg, Fort Vermilion, Westlock for the first year. So what we see here is in the crude protein. So we have about 9.3% in H1 and Sanfoin, and then the intermediate wheatgrass we have about 9.7. Also in the total digestible nutrients. But then moving forward to the next year, we see an increase from 9.3 to 8.5, 11.5, and 11.3, and also in the TDN, we can see a lot of increase, and this goes across all of the sites. So this is actually a very promising finding. So I'm just going to move on to, so this is what I was trying to refer to. So this is actually a very interesting finding from this nutrient. And of course, this Sanfoin is very palatable to livestock because they contain tannins, which helps them and kind of prevent bloating in most of these livestock. So it is actually a very interesting to see how we can improve the forage quality from the first year. Within a span of 2 years, we can see some changes in this forage quality. So the next part is to discuss a little bit how we estimated the nitrogen contribution from these legumes. So in early May of 2024 and in 2023, we started an experiment to investigate how much nitrogen we can harness from the atmosphere. And as you can see, this is how we kind of set this up by labeling, isotopic labeling. I'm not going to go much into details about that. But basically what we're trying to do is to trace how much nitrogen we can get from the legumes, and not just how much we can obtain from the atmosphere, but also how much we're able to transfer from the legumes to the perennial cereals. And from the analysis, we have from the sites. So these are each of these panels represent the sites. So this is from Barhead. I'm sorry about the names, but Barhead basically is from Grow, from Westlock. So this is Breton plots, and this one is for Fayview, and here is for Forestburg. We were not able to investigate the nitrogen fixation from Mara, which is Fort Vermilion side, because like I mentioned earlier, we had a problem with the legume establishment. So we didn't think it was necessary to look in details about the nitrogen contribution from that site. But from what we see here, I'm not sure if this is clear, but the highest nitrogen derived from the atmosphere, we call it NDFA, from Barhead side was about 87.8% nitrogen, and from Breton side was about 91.3%. Fairview, on the other hand, had the highest NDFA on average from intermediate wheatgrass, which is about 93%. And Forestburg was about 90. I'm sorry about that. Forestburg had more nitrogen derived from atmospheric from the atmosphere, about 94.3%. So we want to translate that in what it means in nitrogen per kilogram. Sorry, nitrogen per pounds. Pounds per nitrogen per acre. I always get it confused as I'm used with the metric system. Pardon me about that. But so going back to the panels again, this is Westlock from Grow. We were able to see the highest nitrogen fixed in pound per acre. About 110.7 pounds per acre of nitrogen was actually being fixed by these legumes in the second production year in 2024. And from Breton plots, we had about 116.7 pound per acre of nitrogen being fixed. And this was under intermediate wheatgrass and alfalfa intercropping. And at Fairview, we had a record high of 120.6 pounds per acre of nitrogen being fixed by H1 and alfalfa combination. So this is very interesting just to see that from this intercropping, from these legumes, we were able to obtain this amount of nitrogen. So, so one thing is about the nitrogen being able to fix, but also how much nitrogen is being transferred from the legumes to the perennial. So we also estimated how much in percentage, in pounds per acre. So the panel here represents the sites. As you can see, Barhead here is the one in the red, and you can see Breton in the green, and Fairview is in the in the blue. Well, with Forestburg in the purple. So this is just to give you an idea of how much nitrogen, not just that is fixed, but also being transferred to the neighboring plant. In this case, the intermediate from the legumes, alfalfa, sainfoin or white clover to the perennial cereals. So yes, from what we see here is that between 5.25 pound nitrogen per acre and 117.5 pound nitrogen pound per acre of nitrogen was transferred from the legumes to the perennial cereal grain crops. So I'm going to talk briefly about the soil health improvement, soil health gains from this intercropping. So basically, we know soil health is not just about the physical soil health in terms of the compaction or the texture, but also we have the chemical part of the soil health, which is about the soil organic matter, the mineral composition, and as well as the biological properties. So in this research, we cover all of these, and we're trying to see how the intercropping had influenced the soil in these properties. But for this presentation, we have only soil physical properties to share. So I'm going to just briefly tell you how we went about doing the soil physical analysis. So what we did here was we went across the site and we collected soil samples for 2 depths. So basically we collect intact soil cores And we analyze them in the lab. We use a system and a modeling protocol, and then we're able to obtain and to gain an insight on how this intercropping had improved over the 2 years of establishment. So from what we have here, so these are the sites. So we came up with an index. So so this S index is a combination of all of the soil physical properties. We have the bog density, the soil texture, the porosity, and we model all of them into a unit. We call it the S index. So from what you see here is the threshold. So any number that crosses the benchmark of 0.035, we consider that as a good improvement. So this is it's a little bit more technical, but basically what this tells us is that intercropping here, in this case, we only evaluated alfalfa because that is the most deep-rooted of all of the legumes. So we could see that most of the intercrops they're not exactly greater than 0.035, but they were closer compared to the monocrops. And we can see different variations across the site. But what this tells us is that intercropping has a potential to improve the soil bog density, the soil porosity, and overall soil physical health. So just from what we have now, of course, we have to mention there are some challenges that we face. Although we have this grain and forage yield potentials, we also have the soil improvement. But I'm going to briefly talk about some of the challenges that we're facing with this system. And of course, there's always a trade-off in terms of yield because, of course, we cannot compare the years with the annual. So it's we are still a little bit far in that aspect, but we have a lot of promising benefit from this cropping system. Of course, also, as I mentioned earlier, in some of the site, we were not able to get the yield for grain and for forage. No, sorry, mostly for grain. And this happened because of environmental factors such as the winter. So when it's in winter, maybe some of these um, perennials, they have some problem with the regrowth. And this, varies across site, but basically this is something that affects this cropping system. So in summary, we can see that there's a strong potential for this dual purpose of grain and forage. Of course, they also provide us some other ecosystem service, such as soil erosion control, and this is more beneficial when you compare the annuals to these perennials. And of course, there are differences in their maturity. Of course, each of you have seen from the result we have that they have varied. They are highly variable in terms of yield, as they behave differently, they regrow differently. But we can see a lot of potential in this. So yes, we can see that intercropping can improve the forage yield and also the quality, and also the contribution in the terms of nitrogen has been a very good and a promising finding from this work. So this is all I have, and I want to say thank you to the sponsors of this research, ARDA. They have been the ones sponsoring this project, and I am very grateful to our partner sites, PCBFA. Dr. Hakim is also my PhD committee member, and at GROW, I want to say thank you to all of you guys. And yes, luckily I included Kara here. This is a Oyen. They have been very helpful in terms of the soil analysis. And Mara has also been a key part of this research. And Forestburg, the Battle River Research Group, they've been very wonderful. We also collaborate with AFC. Patrick helps us with the nitrogen fixation analysis. And thank you, everybody. And most importantly, my professor, my supervisor, he has been a highly supportful and highly helpful in terms of giving me the directions, and his input and correction has always kept me working hard. And thank you. That's all I have. I have some time to take some questions, but thank you very much for listening.
Thank you, Cosmos, and thank you, Dr. Hayford. Now we'll take some questions. If anyone has any questions, please write in the Q&A section. You can use the Q&A section to write your query. So there is one question from Kent. How much rainfall was at each plot? You are muted. Actually, you have to. Cosmos, you have to unmute your microphone. We can't hear you. Actually, your microphone is muted.
Sorry about that. So I didn't get the question very well. Can you please repeat that?
So Kent asked how much rainfall was at each plot.
Okay. Well, I do not have the actual amount of rain offhand, but I can just share a little bit of what we have, if that's okay. I can have just give me a second. I can. But what we know is that there are different, there's the rainfall pattern is different across the province. So I'm just going to give, I'm going to stop sharing and share another, just to give an overview of what we have. Okay, so Ken, thank you very much. So this is what we have here. These are the sites we worked at, and this is Barhead. So in 2022, we had about 20, yeah. So this is the average of the sites. So looking at the cumulative, we can say in 2022, for example, Forage bauxite had about 267 millimeter per month on average. And so they are very highly varied, but we can say that at all across the site, Fort Vermilion had the least in terms of amount of rainfall, and Breton plots, although it's not included in this slide I'm sharing, had the highest amount of rainfall. But yeah, it's highly varied, so I don't really have exact number for that rainfall. Yes.
So there is another question from Ken. Can you describe the seeding methods of intercropping and some row cropping?
Somewhat.
Okay. Sorry, did you mean the seeding methods?
Yeah, seeding methods of intercropping and same row cropping.
Okay. So basically, in the same row, let me start with the same row. In the same row, we have the perennial cereals and the legume in the same row. So it's more like it's a mixed cropping. But in the alternate row, you have the perennial cereals and the legumes alternating each other. So it's not really in the same row. But for the monoculture, we have all the monocultures, or just the single, just the monoculture. There's no intercropping with that.
So there are two questions from Blasius. The first one is, do you plan to do any economic analysis to put an economic value on these benefits?
That's actually a very good question. Thank you very much, Blasius. Yes, we part of the project is about the economic benefit from this cropping system. Although I am not directly involved with that project, but yes, that analysis will be done. Although another graduate student will be in charge of that.
And there is another question from Glacius. Are your forage yields on DM basis?
Yes, those are on dry matter basis. Yes.
We'll wait for 1 more minute if anyone has a question. Okay, so there is another question which says, which crop would you grow after your perennial intercrops?
If I understand that correctly, which other crops I'm going to look at after?
So the question is, which crop would you grow after your perennial intercrops?
That's a very good question. For now, I have no, I've not thought about that, but I think, um, so if I understand very correctly, is it based on the crop rotation sequence, or because I think I am not very clear about this question, to be honest. Sorry.
So Hernandez, can you please explain your question a little bit?
Oh, that's
So can I come?
yes, please.
Yes.
So did he mean that like what crop you are going to grow after you've terminated this perennial and perennial cereals, the legume and cereal? Is that what he meant?
So the question says, which crop would you grow after your perennial intercrops? This is the question. It didn't say more. So if you go in
Yeah,
the
that's
Q&A
a very good
section,
question. Yes,
yeah,
I think that's a very good question. Yeah, because I think in terms of the crop to be grown after this system, it could be any crop, but I think canola is always going to be the most favorable because this is what,
yeah.
for example, most of the sites we are established had a canola rotation, and I believe after this intercropping, there will be. We hope to have more more soil improvement. So canola would actually perform very well in this system.
Yeah, I agree. I agree with that because we already have perennial cereals in there. So maybe following it with an annual, which is also cereal, you might end up having a lot of volunteer rye and volunteer wheat in there. So you would want to probably avoid that for now and probably go ahead with the canola to break the cycle, and then probably you can go back.
Thank you very much. That's a very good clarification, Hayford.
There is one question from Jordan. Uh, the question is, how many years do you expect the stands to produce for?
That's a very good question. Thank you, Jordan. Ideally, perennial crops, we would say about 4 years. Although, like I said, it goes with a lot of risk because sometimes in this part of Canada where we have bad and long winters. So yes, but on average we would say 4 years. But sometimes we have the yield reduces as as the years goes by, but on average, we would say 4 years would be a safe lifespan for these perennials.
Yeah.
There is another.
Oh, there's
Sorry.
another one. Okay. So yeah, to add to that, yeah, probably well, perennials will probably want to, and with my observation here at the Fairview Research site, I mean, last year, even though we did not harvest it because the project is almost ending, we saw a lot of good growth in there. The only thing that was a bit, should I say, a bit challenging or off was the fact that, as he said, with the years going by, I realized that some of the rye plots are kind of thinning out. So that is my observation here at the research farm.
So there is another question which says, is ergot a problem in perennial rye that you studied? Ergot.
That's a very good question. Thank you very much. Yes. So we experienced ergot infestation in at some of these sites. So that is very common, especially in perennial rye grasses. So we had that ergot infestation, and yeah, unfortunately, that's also a challenge in these perennials. But regardless, we were still able to obtain a reasonable yield in terms of grain and forages. Yeah.
Am I missing any question, guys? If I have left any question, you can repeat your question, please, in the Q&A section.
So Cosmos, I know I'm doing this side by side with you, but I'm quite sure that you didn't harvest the plots at all sites at the same time, obviously. Do you think if we had harvested all of them, let's say we harvested them on the same day, let's say, would you think it would have influenced any of your results that you got in terms of yield or nutritional value?
That's a very good question. Yes. Yes. So I would just focus on the nutritional value of these forages. So the short answer is yes, because the longer these forages stay in the soil, the more they either accumulate a lot of nutrients or lose a lot of nutrients. So so if I have a uniform sampling date across the site, maybe that could have influenced some of the yield values that we see. But in field research, it's almost impossible to have everything. So so the short answer is yes, but to what extent, that's something we have not verified yet.
Okay. So I have a last question. So I'm a producer, and probably I'm convinced about your work. So I kind of want to go into it. With all the experience you've had over the 2-3 years, what would you tell me to do? Would you encourage me to go ahead and establish this, or you would probably ask me to go ahead, but with some caution? What would you tell me as a producer?
Well, as a producer, as I mentioned in there's always a trade-off. So if you are looking for sustainability, if in terms of soil health benefit, I would say yes. But in terms of most of the producers, they are they're able to obtain a lot of higher yield from the annuals. So um, the profit margin may be an issue, but in terms of sustainable farming, yes, I would recommend perennial intercropping.
Thanks.
Thank you. I'm sorry, we cannot hear you. I think you're trying to say something, Mr. Patek. We were not hearing.
Oh, yeah. Sorry, my bad. Yeah, so I cannot see any more questions. So I think we'll sum up this webinar today here. Thank you everyone for joining us today. Thank you to our presenters for their time. If anyone has any more questions, please feel free to reach out to PCBFA. Have a great evening, everyone. Thank you.
Thank you, everyone.
Thank you very much. Well, have a great night.
Bye, guys.
Yeah, bye.